Today we're going through practice questions on integers and prime numbers. We'll go through 5 questions and 1 bonus one, if you're up for the challenge. Write down A positive integer, B, a negative integer. An integer is any whole number, positive, negative, or 0. So for A, we can write something like 5 because a positive integer is any whole number greater than 0. So 1, 2, 3, 10, 100, any of them will do. For B, we'll write -3 because a negative integer is any whole number that is less than 0. So -1, -2, -10, -50, any will do. That's it. As long as you're choosing whole numbers, you're in the right category. Next question. Is 0 an integer? Give a reason for your answer. The answer is yes. 0 is an integer because integers include all positive whole numbers, all negative whole numbers, and 0 in the middle. Even though it's neither positive or negative, it counts as an integer. Question 3. Write down all the prime numbers between 10 and 30. A prime number has exactly 2 different factors, 1 and itself. That means the number can only be evenly divided by 1 and itself without leaving a remainder. When you try to divide it with other numbers, you always get a remainder. Let's go through them one by one. 11. It can be perfectly divided by 1 and itself without leaving a remainder. But 2, 3, 4, 5, 6, 7, 8, 9, and 10 all leave a remainder, so they are not factors of 11. That is why we conclude that 11 is a prime number. What about 12? In addition to the 2 factors of 1 and itself, we can divide it perfectly by 2 and 3. That is already too many factors, so 12 is not a prime number. 13? It is a prime number because only dividing it by 1 and 13 won't leave a remainder. All the other numbers, which is 2 to 12, leave a remainder. And here's a trick. You don't have to divide the number with all these numbers. When solving this problem, all you need to check is if the number has a third factor to disqualify it as a prime number. Because, remember, a prime number only has 2 factors. Let's try this with 14. So in addition to the 1 and itself, we'll divide it by 2. That does not leave a remainder, so it is not a prime. It is divisible by 2, so now it has more than 2 factors. How about 15? Again, we try the 1 and itself, just to help you remember this. But 2 leaves a remainder. When you divide it by 2, you have a remainder, but 3 doesn't. And that means now we already have more than 2 factors, and this disqualifies it as a prime number. Now pause the video and keep going all the way to 30. The more questions you do, most of this is really just mental work, so hopefully these are the numbers that you got. 11, 13, 17, 19, 23, and 29. These are the prime numbers between 10 and 30. Question 4. Is 51 a prime number? Explain your answer. To qualify as a prime number, it must only be divisible by 1 and itself without leaving a remainder. So let's try 2. It's leaving a remainder. What about 3? 51 divided by 3 gives you 17. So now 51 has more than 2 factors, and that means it is not a prime number. Question 5. Circle all the prime numbers in this list. Try this mentally, and we'll list the factors of each below each number, starting with 1 and itself. So a prime number should only have these two factors. 4 has the following factors. You can divide it by 1, you can divide it by itself, and you can also divide it by 2 without leaving a remainder. So that disqualifies it as a prime number. 7 has 1 and 7 only, so it is a prime number. 9 has 1 itself, and 3 can also divide into 9 without leaving a remainder. So it is disqualified. 11 has 1 and 11, which is itself. That is only 2 factors, so it is a prime number. In addition to 1 and 15, 3 and 5 can also divide into 15 without leaving a remainder, so that means 15 is not a prime number. 17 has the following factors, 1 and 17. Therefore, it is a prime number. So you should circle the following numbers, 7, 11, and 17. And now for the bonus question. If you prefer a faster way of working out prime number problems, especially when the numbers get bigger, this will be a useful practice for you. Is 101 a prime number? You definitely don't want to divide this with all the numbers from 2 to 100. So here's a simple logic that you can follow. 101 is an odd number. So we know that odd numbers always leave a remainder when you divide them by 2. You can divide it by 3. An even simpler way would be to add the digits of 101 to say 1 plus 0 plus 1. You get 2, and then you divide that by 3. Both methods leave a remainder, so that means you can't divide this number by 3. 101 doesn't end in 0 or 5, so we know because of that you can't divide it by 5 without leaving a remainder. 107 divided by 7 will give you 14.4, which is not a whole number. If you divide this by 11, you get 9,18, which is also not a whole number. You can try all the other bigger prime numbers, 13, 17, 19, 23, 31, but that is such a long route for such a big number. So you can skip all of that to the last and final confirmation that you need, which would be to find the square root of 101. If it is not a whole number, in which case it is not a whole number, that means 101 is a prime. So 101 is a prime number. Hope you've learned something. See you in the next practice lesson.